Hi everyone, welcome to the Digu Science channel. How are you today? I hope you're all doing well. In this series, we'll learn about galvanometers. Here's a 3D rendering of a galvanometer. This tool is commonly used to determine the direction of an electric current. Let's take a look at what's inside. First, there are the plugs. These plugs are intentionally colored differently so we can tell whether the current entering the galvanometer is coming from the red or black plug. Therefore, in practice, the red wire will be connected to the red plug, and the black wire will be connected to the black plug. Second, there's the current value. If we're used to using an ammeter, the zero mark will be at the far left end. This isn't the case with a galvanometer. On a galvanometer, the zero mark is right in the middle. To the right of the zero mark are several values, so the rightmost value is the largest. To the left of the zero mark is also a value. The leftmost value is also the largest. The values on the right and left are arranged symmetrically. These values represent the current flowing through the galvanometer. A galvanometer can detect very small currents on the microampere scale. Currents this small cannot be detected by an ammeter. So, what if we want to determine the direction of the current at large currents? We can install a resistor in the wire around the plug. When passed through the resistor, the current will decrease drastically, as can be detected by the galvanometer. The third element is the needle. This needle can deflect to the right or to the left. This needle deflection indicates the direction of the electric current. An ammeter does not have this feature. The ammeter needle will always deflect to the right regardless of the direction of the electric current. We can say that an ammeter only measures electric current. Now, let's look at galvanometers available on the market. Here are two galvanometers. Although they look exactly the same, they operate differently. When electric current flows from left to right, or from the black wire to the red wire, the needle on the left galvanometer deflects to the left. Meanwhile, the right galvanometer needle deflects to the right. Why is this? Because the electrical circuit inside the galvanometer is different. We will discuss this in detail in the next series. Conversely, when electric current flows from right to left, or from the red wire to the black wire, the left galvanometer needle deflects to the right. Meanwhile, the left galvanometer needle deflects to the left. If there are two types of galvanometers on the market, which one should we choose? We can't choose. We must try to flow the current in a known direction, such as connecting the galvanometer to a battery. We only know which galvanometer we have. In this series, we will use this galvanometer. In other channels, this may not be the case. This galvanometer is simply a tool. We can draw this tool on paper. We can draw the letter G inside a circle. This is the symbol for a galvanometer. Or a circle with an upward arrow. For this galvanometer, the needle deflects always away from the direction of the incoming electric current. Hopefully, this tutorial has provided an overview of galvanometers. And don't forget to watch the next video.
I am waiting for a bus at the